Welcome back, dear dreamer. Tonight, we drift into the peaceful world of starlight, where every glow begins in silence and travels across space for ages before reaching your eyes. Above us, countless suns breathe with steady patience, guiding the night without hurry or sound. As you listen, let your thoughts slow down and settle, the way distant light softens as it moves through the dark. There is nothing to solve and nowhere to be. Just allow each moment to unfold at its own quiet pace. If these gentle journeys bring you comfort, remember to subscribe and tap the like button. Now, let us begin. Inside a quiet cloud of dust and gas, a star begins its life without any sound or rush. Gravity slowly gathers tiny particles together, letting temperature rise in the hidden center. Nothing seems to happen from the outside, yet deep inside the nebula, pressure increases until the first soft light appears. A newborn star does not burst into existence. It grows brighter little by little, learning how to shine as the universe watches in silence. These clouds drift for millions of years before a single star forms, reminding us that creation often begins quietly. What looks empty from far away is actually full of potential, waiting for the right moment to glow. When you look at the night sky, you are seeing light that started traveling toward Earth long before you were born. Some of the stars shining tonight began their journey before humans learned to write or build cities. Space stretches across unimaginable distances, so light needs thousands or even millions of years to arrive. You are witnessing moments that already ended, still moving forward through darkness like gentle memories that refuse to fade. The sky above is not just a view of the present, it is a peaceful window into the past, carrying stories from ages we will never experience but can still appreciate. Ancient civilizations found comfort in the night sky, long before telescopes existed. People noticed patterns in the stars and shaped them into constellations that helped them remember seasons, track time, and guide travel across open land and sea. The North Star became a steady companion because it almost never moves from its position, giving direction even in complete darkness. For early observers, the sky was not mysterious. It was familiar, dependable, and filled with meaning. They passed stories from one generation to another, believing the heavens offered protection and wisdom. Even today, those same constellations remain above us, unchanged and patient, reminding us that some things stay steady no matter how much life changes below. Every star begins inside a nebula, surrounded by swirling materials that seem soft and hazy from a distance. Gravity gently pulls particles closer until the center becomes hot enough for nuclear fusion to start. This process allows a star to shine for billions of years without making a sound. Even though it looks delicate, the energy inside a star is powerful, enough to keep entire solar systems stable. Our sun is one example, providing warmth and light that supports life on Earth while staying calm and steady from morning to night. Stars teach us that something can be peaceful and strong at the same time, glowing with a patience that outlasts everything around it. The elements inside your body were formed in the hearts of ancient stars. As a star grows older, it creates heavier elements like carbon, oxygen, and iron through fusion in its core. When the star reaches the end of its life, it releases these materials into space, scattering them like dust across the universe. Over time, these elements become part of new stars, planets, and eventually living beings. This means the calcium in your bones and the iron in your blood were once part of a distant sun that no longer exists. Even though we feel separate from the universe, we are built from the same starlight that shines quietly above us each night. star's color reveals its temperature, creating a peaceful rainbow across the sky. Cooler stars glow in soft shades of orange and red, while hotter stars appear white or blue. To the human eye, the night seems still, but every star is moving through space at incredible speed. We cannot notice this motion because distance makes everything appear frozen in place. The universe operates on a slower rhythm than our daily lives, teaching us patience without saying a word. When you look upward, the colors you see come from heat, age, and distance, blending into a gentle display that has continued for billions of years. The sky reminds us that even small details can carry deep meaning. The twinkling of a star is not caused by the star itself, but by the air surrounding our planet. As starlight passes through different layers of Earth's atmosphere, it bends slightly, creating a shimmer that appears to flicker. In space, stars shine steadily without interruption. It is only from the ground that they seem to sparkle, like small reflections on water. This gentle movement gives the sky a soothing and dreamlike feeling. The universe remains calm and steady, while our atmosphere adds a soft motion that makes the night feel alive. The twinkling is a quiet reminder that beauty can come from the simplest interaction between light and air. Many stars do not live alone. Some exist in pairs, orbiting around each other like silent companions who never touch, yet remain connected by gravity. These systems are called binary stars, and they move in smooth patterns that can last for millions of years. Other stars form in clusters, gathering hundreds or thousands together from the same cloud. Even in the vast openness of space, nothing is completely isolated. The universe is full of relationships that continue without noise or interruption. These gentle connections show that companionship can exist anywhere, even where silence dominates. The stars above remind us that there is comfort in simply sharing space with others, without needing to rush or change. Meteor showers come from tiny particles left behind by comets that travel through the solar system. When Earth passes through these trails, the particles enter our atmosphere and burn softly, creating streaks of light that disappear almost as soon as they form. People often make wishes when they see them, even though the moment lasts only a second. The beauty of a meteor shower is not in its length, but in its peaceful arrival and gentle exit. It reminds us that brief experiences can still feel meaningful. The sky offers these quiet displays without schedule or warning, allowing anyone awake at the right moment to witness something small and unforgettable. Red giant stars are nearing the final stage of their life. Over time, they use up the fuel in their core and begin to expand, becoming much larger while their outer layers cool and turn red. Even our sun will one day become a red giant, though this will not happen for billions of years. The transformation is slow and calm, taking place over an immense stretch of time. Eventually, the star releases its outer layers into space, leaving behind a glowing core called a white dwarf. This ending is gentle rather than violent, showing that even powerful stars fade with grace. The universe moves with patience, reminding us that every cycle has its own quiet rhythm. In the darkest parts of space, stars are forming right now inside thick clouds called molecular nebulae. These regions look completely black because dust blocks visible light, hiding everything within. Telescopes that detect infrared can see through the darkness and reveal tiny glowing points that are still growing. These newborn stars are called protostars, slowly gathering more material as gravity pulls gas inward. The process can take millions of years, happening so gradually that nothing seems to change. Yet deep inside, heat continues to rise until fusion begins and a new star quietly turns on its light. Even when the universe appears still, creation is always happening in hidden places that wait patiently before revealing themselves. Some stars spin at incredible speeds, completing full rotations much faster than planets. A young star can spin so quickly that its shape becomes slightly flattened at the poles, stretching outward at the sides. Over time, stars slow down as magnetic fields and stellar winds carry energy away. Our sun once spun much faster in its youth, but now completes a rotation in about 27 days. From Earth, we cannot see this movement, yet it influences activity on the sun's surface, including gentle streams of charged particles that eventually reach us. Even something that seems motionless holds a quiet rhythm. Stars remind us that movement does not always need to be visible to be real. There are stars so massive that their lives are dramatically shorter than smaller ones. These giants burn through their fuel quickly, shining with intense brightness for only a few million years. Their cores create heavy elements at a rapid pace until they can no longer support their weight. When that moment arrives, the star collapses and explodes into a supernova, releasing energy brighter than entire galaxies for a brief time. Although the event is powerful, its aftermath is peaceful, scattering elements into space that eventually become part of new systems. Massive stars teach us that even short-lived moments can leave lasting effects. Their endings create the building blocks for planets, life, and future starlight. Not all stars shine equally bright. Some are so faint that even with clear skies, the human eye cannot detect them without help. These dim stars are often small red dwarfs, burning fuel slowly and steadily for trillions of years. Their gentle glow makes them nearly invisible from Earth, yet they are the most common type of star in the universe. Our galaxy is filled with them, quietly existing without drawing attention. Their long lifespans mean they will continue to shine long after brighter stars have faded. The idea that the universe is supported by countless quiet and unseen lights offers a comforting thought. Strength does not always appear obvious. Sometimes it works softly, without needing to be noticed. When starlight travels through space, it stretches as the universe expands. This stretching changes the light's wavelength, shifting it toward the red end of the spectrum. Scientists call this redshift, and it helps measure how far away stars and galaxies are. The greater the shift, the longer the light has been traveling. It means the universe is not static, but gently growing in all directions. Even though expansion happens slowly, its effect is visible across cosmic distances. The night sky becomes a record of movement that we cannot feel but can observe through patient study. Redshift shows that time and space are connected, and the universe continues unfolding with quiet steadiness. Some stars end their lives by collapsing into incredibly dense objects called neutron stars. These remnants are only a few kilometers wide, yet contain more mass than the Sun. A teaspoon of neutron star material would weigh billions of tons. Despite their extreme nature, neutron stars can produce gentle, rhythmic pulses of radio waves as they spin. These objects, called pulsars, act like cosmic lighthouses, sending regular signals through space. The pulses are steady and predictable, continuing for millions of years without interruption. Even after a star has died, it can leave behind a calm and dependable pattern, reminding us that endings can still carry quiet purpose. The sun produces a gentle flow of charged particles called the solar wind. This stream travels outward through the solar system, carrying energy far beyond the planets. When these particles reach Earth, they interact with the magnetic field and atmosphere, creating soft displays of light near the poles known as auroras. The colors appear slowly, moving like curtains that shift across the sky. Although the sun is powerful, most of its wind reaches us in a calm and steady way, supporting the balance of space around our planet. The auroras are a peaceful reminder that even distant forces can create beauty without sound or disruption. Throughout history, different cultures used stars to keep track of time. Before mechanical clocks, people noticed how certain stars rose or set during particular seasons. Farmers planted crops based on the return of familiar constellations, and sailors crossed vast oceans guided by predictable patterns in the sky. The stars became a natural calendar that required no tools, only patience and observation. Even today, the same celestial cycles continue, unchanged by centuries of human life. The night sky connects us with people who lived long before us, offering the same steady signals they once trusted. It shows that time can be measured without rushing, simply by watching the universe move at its own pace. Some stars are surrounded by disks of dust and ice, forming the early stages of planetary systems. Over millions of years, tiny particles collide and stick together, slowly growing into larger bodies. Eventually, planets, moons, and asteroids take shape, orbiting their star in a stable pattern. Our solar system began this way, starting with a cloud that flattened into a spinning disk before the sun formed at its center. Even though we cannot see this process with the naked eye, telescopes capture young systems in different stages of development. These quiet transformations show that creation does not happen suddenly. It unfolds slowly, allowing worlds to form in silence before they are ready to shine. Although stars seem eternal, they follow predictable life cycles based on their size and mass. Small stars burn fuel slowly and may live longer than the current age of the universe. Medium stars like the sun remain stable for billions of years before becoming red giants and fading into white dwarfs. Massive stars live fast and end suddenly, creating supernovae or black holes. Each path is calm and steady, guided by physics rather than chance. This order brings a sense of peace, showing that the universe moves with structure instead of chaos. Even the largest and brightest stars follow gentle rules, reminding us that everything has a rhythm written into its nature. White dwarf stars are the quiet remnants left behind after a medium-sized star finishes its life. When a star like the sun expands into a red giant and releases its outer layers, the core that remains cools slowly over billions of years. A white dwarf no longer produces energy through fusion, but it still shines with leftover heat that fades gradually. These stars are incredibly dense, packing mass similar to the sun into a space about the size of Earth. From far away, they appear gentle and harmless, glowing softly without change. Their slow cooling shows that endings do not always arrive suddenly. Sometimes they take their time, continuing to give light long after their brightest moments have passed. A supernova is one of the most powerful events in the universe, yet it plays an important role in creating calm and balance. When a massive star can no longer support itself, it collapses and releases an enormous burst of energy that can outshine entire galaxies for a short time. Although the explosion is intense, the aftermath is peaceful. The materials spread into space and enrich the surrounding clouds with elements that become part of new stars and planets. Without supernovae, many essential elements would never exist. This cycle shows that even dramatic endings can lead to quiet beginnings. The universe reshapes itself gently, allowing new light to form from what once faded. The sun may look the same every day, but its surface is constantly changing in subtle ways. Dark areas called sunspots appear when magnetic activity becomes stronger in certain regions. These spots are cooler than the surrounding surface, even though they are still extremely hot. Sunspots follow an 11-year cycle, where activity increases and then slowly decreases again. Most of the time, the sun stays calm and steady, giving Earth light and warmth without interruption. Its predictable nature supports life and guides the rhythm of days, seasons, and climate. Watching the sun reminds us that even steady things have small variations. Stability does not require complete stillness. It can include gentle changes that happen quietly and return to balance. The Milky Way contains hundreds of billions of stars, yet only a small fraction are visible to the human eye. When we look up from a dark and clear location, the faint band stretching across the sky is our view from inside the galaxy. What appears like a soft, clouded ribbon is actually the combined light of countless distant stars. The center of the Milky Way is filled with dense clusters and a supermassive black hole that holds the galaxy together. Even though we cannot see all of it directly, the presence of the Milky Way gives a feeling of belonging. We are part of a much larger system that moves gently through space, carrying stars and worlds with quiet grace. Open star clusters are groups of young stars that formed from the same cloud and remain loosely connected by gravity. These clusters can contain a few dozen to a few thousand stars, all shining with a similar age and brightness. Over time, the stars slowly drift apart as they interact with the galaxy's motion. Well-known examples like the Pleiades are visible without a telescope, appearing as small, shimmering groups in the night sky. Open clusters offer a peaceful reminder of shared beginnings. They show that even when paths eventually separate, origins remain connected. The stars move forward gently, continuing their journey across the galaxy while carrying the memory of where they first formed. Globular clusters are different from open clusters because they contain hundreds of thousands of old stars packed closely together. These spherical groups orbit the outer regions of galaxies and have existed for more than 10 billion years. From a distance, they look like glowing snowballs hanging in the dark. The stars inside them are ancient and stable, burning quietly after long lives. Globular clusters act like time capsules, holding some of the oldest visible stars in the universe. Observing them helps scientists understand how galaxies formed and evolved. Their steady presence shows that some structures remain unchanged for extraordinary periods. In a universe filled with motion and transformation, globular clusters offer a sense of calm continuity. Variable stars change their brightness over time in regular patterns. Some expand and contract slowly, causing their light to increase and fade in a steady rhythm. These gentle cycles can last days, months, or even years. By studying variable stars, astronomers can measure distances across space because their brightness follows predictable rules. One type, called Cepheid variables, helped reveal that galaxies lie far beyond the Milky Way. Even though their light changes, the pattern remains reliable, creating a quiet heartbeat in the sky. Variable stars show that fluctuation does not mean instability. It can be a natural rhythm that repeats with patience, offering information and reassurance across great distances. The brightest star in the night sky is Sirius, located in the constellation Canis Major. Although it appears as a single star to the eye, Sirius is actually a binary system with two stars orbiting one another. It shines so brightly because it is relatively close to Earth and emits strong light. Throughout history, different cultures have honored Sirius with stories and seasonal significance. Its rising marked the flooding of the Nile in ancient Egypt, helping guide agriculture and life. Today, Sirius remains a familiar sight that appears crisp and steady on clear nights. Its consistent presence brings comfort, reminding us that the sky offers reliable markers that return year after year without change. Stars emit energy in the form of light, but they also release particles that create gentle pressure, called radiation pressure. This outward force balances the inward pull of gravity, allowing a star to remain stable for most of its life. When the balance is maintained, the star shines calmly without collapsing or expanding rapidly. This harmony continues for millions or billions of years, depending on the star's size. The concept is simple yet powerful, two opposing forces working together to create peace. Radiation pressure demonstrates that stability comes from balance rather than strength alone. A star glows steadily because its inner and outer forces match, creating a quiet equilibrium that lasts across unimaginable spans of time. Brown dwarfs are often called failed stars because they form like stars but never reach the temperature needed for sustained fusion. They are larger than planets, but smaller than true stars, glowing faintly in infrared light. Brown dwarfs drift through space quietly, often unnoticed, because they are dim and cool. Although they do not shine brightly, they help bridge the understanding between planets and stars. Their presence shows that the universe includes many forms that do not fit neatly into one category. Brown dwarfs remind us that not everything needs to reach a traditional definition to have purpose. Even without a brilliant shine, they exist patiently, contributing to the calm diversity of the cosmos. Some stars are surrounded by gentle shells of glowing gas called planetary nebulae, formed when a dying star releases its outer layers into space. Despite the name, these nebulae have nothing to do with planets. They were named by early astronomers because their round shapes looked similar through small telescopes. The gas spreads outward slowly, creating colorful patterns that last only a few tens of thousands of years, which is brief on a cosmic scale. At the center rests the fading core of the original star, shining softly as it cools. Planetary nebulae are like quiet farewells, marking the transition from one stage of life to the next. They show that endings can be gentle, beautiful, and filled with light. The chemical fingerprints of stars allow scientists to understand what they are made of without ever touching them. When starlight passes through a prism or special instrument, it separates into thin lines of color, known as a spectrum. Each element creates a unique pattern, like a signature that reveals whether a star contains hydrogen, helium, oxygen, or heavier materials. This method helps astronomers learn about temperature, age, and even movement. The process is calm and non-invasive, relying only on the careful study of light. It proves that knowledge does not always come from direct contact. Sometimes it arrives quietly, through observation and patience, allowing us to understand distant objects that will never be within reach. Some stars act as quiet anchors that guide spacecraft across deep space. Instead of relying only on signals from Earth, navigation systems can measure a craft's position by comparing the light from known stars. Pulsars, with their steady timing, provide especially reliable reference points. Their rhythmic pulses are so consistent that they have been compared to cosmic clocks. Using stars for navigation continues a tradition that began with ancient sailors who steered across oceans at night. Now the same idea helps spacecraft travel millions of kilometers with precision. The sky offers guidance without noise or force, simply by existing with stability. Stars remind us that direction can come from steady signals that require nothing more than trust and attention. The closest star to Earth, apart from the Sun, is Proxima Centauri, located just over 4 light-years away. Even though it is relatively near in cosmic terms, it is far beyond the reach of current spacecraft. Proxima is a small red dwarf, faint and cool compared to the Sun, and cannot be seen without a telescope. It hosts at least one planet in its orbit, raising questions about conditions around distant stars. Knowing that our nearest stellar neighbor is quiet and unassuming adds perspective. The universe is vast, yet the stars closest to us are simple and steady rather than dramatic. Proxima Centauri offers a gentle reminder that proximity does not always mean familiarity, and discovery often begins slowly. Light travels at a constant speed, but time behaves differently near strong gravitational fields created by massive stars. According to general relativity, clocks tick slightly slower in regions where gravity is stronger. This effect is subtle and cannot be felt in everyday life, yet it has been measured using precise instruments. The concept shows that time is not a rigid structure, but something that bends gently with the universe. Even though stars seem distant and unconnected to our lives, their gravity influences the flow of time in a measurable way. This idea brings a calming perspective. The universe operates with quiet flexibility, allowing space and time to adapt without sudden changes, creating a steady balance that continues without interruption. Stars can lose material over time in the form of gentle stellar winds. These streams of particles drift outward into space, forming clouds that eventually mix with surrounding regions. The process is slow and steady, shaping the environment over millions of years. In massive stars, the winds are stronger and carry more material, while smaller stars release lighter, calmer flows. These winds help distribute elements across the galaxy, contributing to future star formation. Even though the movement is invisible to the eye, it plays an important role in the quiet recycling of matter. Stellar winds demonstrate that change does not always happen quickly. It can unfold gradually, allowing the universe to evolve in peaceful and continuous cycles. Some stars orbit the centers of galaxies at incredible speeds, yet from within we feel no motion. The Sun completes a full orbit around the Milky Way, approximately every 220 million years. During that time, the galaxy continues rotating, carrying billions of stars in a smooth, coordinated path. There is no sensation of movement because space is vast and empty, allowing everything to glide without resistance. This slow journey reminds us that stability can exist even within constant motion. The universe moves on scales far larger than human experience, offering a calming sense of perspective. While life changes quickly on Earth, our place in the galaxy remains steady and unhurried. Blue supergiant stars are among the hottest and most luminous objects in the universe. They shine intensely, releasing energy at a rate far greater than the Sun, yet their lifespans are surprisingly short. These stars burn through their fuel rapidly and evolve quickly into later stages. Despite their size and brilliance, they remain peaceful from a distance, giving off light that travels across vast space without sound. Their existence shows that brightness does not always equal permanence. Even the most powerful stars eventually soften and fade. The quiet lesson is that everything, no matter how strong, follows a natural rhythm. Blue supergiants remind us that intensity and calmness can coexist without conflict. Stars near the center of the Milky Way experience a very different environment from those in the outer regions. The core of the galaxy is crowded with dense clusters, swirling gas, and a supermassive black hole that influences the motion of nearby objects. Despite these strong forces, many stars remain stable and continue their lives without disruption. The region is hidden from view by dust, but infrared observations reveal a busy space filled with activity that appears calm from far away. This contrast shows that peaceful appearances do not always reflect simple conditions. Even in complex surroundings, order can exist. The galaxy's center demonstrates that balance can be maintained in places that seem intense or overwhelming. The oldest known stars formed shortly after the universe began more than 13 billion years ago. These ancient lights contain very few heavy elements because they were created before supernovae enriched space with new materials. Studying them helps scientists understand the early universe and how the first structures took shape. Even though these stars are fragile and faint, they have survived longer than entire galaxies that once existed. Their endurance offers a quiet message about time and resilience. The universe keeps its earliest memories in the form of starlight that continues to shine across unimaginable distances. These ancient stars remind us that longevity can come from simplicity, and that the past remains present in gentle and enduring ways. Astronomers measure the distance to nearby stars using a gentle method called parallax. As Earth moves around the Sun, a star appears to shift slightly against the background of more distant stars, creating a tiny angle that can be measured with patience and precision. The movement is so small that the human eye cannot notice it, yet it reveals how far away a star truly is. Parallax depends only on observation, not contact, allowing scientists to understand the universe through quiet geometry. This technique shows that even the smallest motion can hold meaning. The stars do not move for us, yet their positions provide answers simply because we are willing to watch and wait without rushing. Some stars form systems where one passes in front of the other, as seen from Earth. These are called eclipsing binaries, and their light appears to dim and brighten in regular, gentle cycles. The change is not chaotic, but predictable, allowing astronomers to learn about the size, temperature, and orbit of each star. These soft variations create a calm rhythm in the night sky, like a slow heartbeat that repeats without interruption. Even though the stars never touch, their shared motion creates harmony that lasts for millions of years. Eclipsing binaries remind us that connection does not require closeness. Sometimes the simple act of moving together is enough to create balance and understanding. When a planet passes in front of its star, the star's light dips slightly in a way that can be measured. This process, called a transit, allows scientists to discover planets around distant suns without ever seeing them directly. The change in brightness is delicate and brief, often less than 1%, yet it carries enormous meaning. By studying these gentle dips, astronomers can learn about a planet's size, orbit, and even the possibility of an atmosphere. The universe reveals new worlds quietly, not through dramatic displays, but through small and patient signals. Transits remind us that discovery often begins with noticing something subtle, allowing unseen places to become part of our understanding through calm observation. Stars contain different amounts of heavy elements, a property called metallicity. Younger stars tend to have higher metallicity because they formed from material enriched by earlier generations of stars that lived and faded before them. Older stars contain mostly hydrogen and helium, reflecting the early universe. By studying metallicity, astronomers can estimate a star's age and origin without disturbing it. The process is peaceful, relying only on light and analysis. This gentle variation reveals how the universe has slowly changed over billions of years. Metallicity shows that time leaves quiet signatures rather than sudden marks. Stars evolve not through noise, but through gradual shifts in composition, carrying a record of history in the calm glow of their light. The Hertzsprung-Russell diagram is a simple but powerful way of understanding stars by comparing brightness and temperature. When plotted on this chart, stars fall into clear patterns that reflect their stage of life. Most stars, including the Sun, lie along the main sequence, where they spend the majority of their existence shining steadily. Other regions show giants, dwarfs, and rare types that have moved into different phases. The diagram offers clarity without complexity, turning countless points of light into an organized picture. It shows that the universe follows gentle structure instead of random behavior. Even with so many stars, patterns emerge naturally, reminding us that order can rise quietly from vastness without force. Runaway stars travel through space at unusually high speeds, often after being pushed away from their original homes by supernova explosions or gravitational interactions. Despite their fast motion, they do not create noise or disturbance. They glide through the galaxy silently, carrying the memory of where they once belonged. Some will eventually drift into regions far from other stars, continuing their journey alone. Their existence shows that paths can change suddenly, yet motion can remain calm. Runaway stars remind us that separation does not always mean chaos. Even after dramatic events, the universe settles back into stillness, allowing objects to move forward without losing their quiet nature. Blue straggler stars are unusual because they appear younger and hotter than the other stars around them. They are often found in old clusters where all stars formed at the same time, yet blue stragglers shine as if they arrived later. Scientists believe they form when two stars merge or transfer material between them. The process is not violent from a distance, and the resulting star continues its life as if renewed. Blue stragglers offer a gentle lesson that appearances can be surprising and that renewal can happen quietly. They show that even in ancient communities of stars, unexpected brightness can emerge without disrupting the calm environment around it. Throughout history, people named stars to create familiarity and guidance in the night sky. Many of the brightest stars still carry ancient names from Arabic, Greek, or Latin traditions, passed down through centuries without change. Modern astronomy uses catalog numbers for clarity, but the old names remain as peaceful reminders of how humans once connected with the heavens. Names like Vega, Altair, and Betelgeuse reflect stories, navigation, and memory. The night sky becomes not just a scientific map, but a gentle archive of cultures that looked upward for comfort and direction. Star names show that meaning can last across generations, carried quietly through time without needing to be rewritten. Dark sky locations allow the stars to appear as they truly are, untouched by artificial light. In these rare places, the Milky Way stretches clearly across the horizon, and faint stars emerge that remain hidden in cities. The experience is calming rather than overwhelming, offering a quiet reminder of scale and presence. People often describe a sense of stillness when seeing the sky this way, as if time slows and the universe becomes more familiar. Dark sky sights show that clarity does not come from adding more light, but from removing distractions. The stars have always been there, waiting patiently for moments when we choose to look without interruption or noise. Some stars orbit so close to black holes that their shape gently stretches due to tidal forces. Even though black holes are known for their strength, these interactions can remain stable for long periods without immediate destruction. The star continues shining while slowly losing material that spirals into the black hole, forming a bright and steady disk. The process is gradual, unfolding over thousands or millions of years. From far away, it appears calm, with no sound or sudden movement. This quiet exchange shows that powerful forces do not always act violently. The universe allows balance even in extreme environments, reminding us that calmness can exist where we least expect it. Some galaxies are filled with regions called stellar nurseries, where thousands of stars form together over long stretches of time. These areas glow softly because young stars heat the surrounding gas, creating gentle colors that spread across space. Even though the process looks bright from far away, everything inside happens slowly and without sound. Clouds contract, fragments separate, and new stars begin their quiet growth. The cycle continues for millions of years before the nursery fades and the stars drift apart. These regions remind us that creation does not need urgency. It unfolds at a natural pace, allowing light to appear only when it is ready. The universe shows patience in the way it builds new places for starlight to begin. Some stars release pulses of energy called flares. These events occur when magnetic fields on the surface shift and reconnect, releasing heat and light into space. While flares on massive stars can be powerful, most happen quietly and fade quickly. Our sun experiences these changes from time to time, yet life continues undisturbed on Earth because distance softens the effect. The process shows that even stable things have moments of activity. Stillness does not require perfection. It can include gentle bursts that come and go without altering the overall balance. Stellar flares remind us that natural systems breathe in their own rhythm, rising and settling again, while maintaining calm across vast stretches of time. As stars age, they gradually change their chemical balance by turning hydrogen into helium through fusion. Over billions of years, the core becomes heavier, and the star adjusts its temperature and brightness in small steps. These changes are slow and steady, impossible to notice from one human lifetime. Yet they guide the star toward its later stages with quiet certainty. The process shows that transformation does not need to be sudden. It can happen gently, guided by rules that never rush. Stars evolve the way mountains erode or oceans shift, through tiny movements that become meaningful only over immense time. Their calm progression offers comfort, reminding us that growth can happen without urgency, pressure, or noise. Some stars move in groups called stellar streams, long ribbons of stars that travel together across the galaxy. These streams were once part of clusters or small galaxies that slowly stretched out as they orbited the Milky Way. From Earth, they are difficult to see, but careful measurements reveal their smooth paths. The stars remain connected even after being pulled apart, following the same direction for billions of years. Their motion is gentle and steady, like a slow river drifting through space. Stellar streams show that separation does not erase history. Even when distance increases, shared origins continue guiding the journey. The universe keeps quiet traces of what once existed, letting old patterns remain without forcing them to disappear. In some binary systems, a white dwarf gently pulls material from a nearby companion star. The transferred gas forms a thin disk around the white dwarf, heating up as it spirals inward. Most of the time, the system remains calm, shining softly with steady light. Occasionally, the buildup becomes warm enough to create a temporary brightening called a nova. Unlike a supernova, this event does not destroy the star. It fades slowly and returns to normal, allowing the cycle to continue. Novae show that even dramatic moments can resolve peacefully, without permanent change. The universe allows release and restoration, giving systems time to return to balance rather than ending in sudden finality. Stars with strong magnetic fields can create beautiful arcs of charged particles around them, similar to the auroras on Earth. These features, called magnetospheres, protect the star and influence nearby space. The fields can trap particles and guide them along invisible paths that produce soft emissions of light or radio waves. Although we cannot hear or see them directly without instruments, the activity remains ordered and controlled. Magnetospheres show that strength does not always appear forceful. It can exist quietly, shaping an environment without disturbance. The presence of a magnetic field brings stability, allowing the star to maintain its structure for long periods. This gentle protection reflects the universe's ability to support balance through unseen forces. Carbon stars are rare, cool stars whose atmospheres contain more carbon than oxygen. The excess carbon forms small particles that scatter light in a way that gives the star a deep red appearance. These stars develop late in their lives as material from the core rises to the surface. The process is slow and unfolds over thousands of years, creating a calm transformation rather than a sudden shift. Carbon stars have been used throughout history as markers in the sky because of their warm color and steady presence. They remind us that beauty can come from subtle change, not only from bright or powerful displays. Their soft glow carries a sense of warmth, like embers that continue shining long after the fire has cooled. When a star moves through space, it creates a gentle wake in the surrounding gas and dust. If the motion is fast enough, the star can form a bow shock, shaped like a smooth curve ahead of its path. This structure is similar to the way water parts around the front of a moving boat. But in space, it happens quietly and without sound. The bow shock glows faintly as particles heat up and cool again. The effect shows that motion can interact with the environment in peaceful ways, creating shapes that last for thousands of years before slowly fading. It is a reminder that even continuous movement can leave soft and temporary traces rather than permanent disruption. Some stars have planets that orbit so closely they complete a full cycle in just a few hours. These worlds experience constant light on one side and permanent night on the other. Despite the extreme conditions, the system remains stable and predictable. The star continues shining, and the planet continues circling without noise or interruption. Observing these systems shows that balance can exist even under unusual circumstances. The universe supports many forms of order, not just the familiar ones. These close orbit planets remind us that harmony does not require similarity or comfort. It can exist in unexpected arrangements, where each part finds its place and continues its rhythm peacefully across time. At the end of their evolution, the smallest and faintest white dwarfs will eventually cool until they no longer emit light. These theoretical objects are called black dwarfs, although none exist yet because the universe is not old enough for one to have formed. The idea represents a quiet conclusion, where a star does not explode or collapse, but simply becomes cold and still. This final stage shows that some endings are silent and complete, arriving only after unimaginable stretches of time. Black dwarfs remind us that not all conclusions need sound, motion, or brightness. The universe allows some stories to fade slowly into rest, carrying the memory of light without needing to shine forever. Sometimes, star formation begins when a gentle shockwave passes through a cloud of gas, slowly compressing it until certain regions become dense enough to collapse. These shockwaves can come from nearby supernovae or the motion of spiral arms in a galaxy. Although the idea sounds dramatic, the process unfolds over millions of years and remains completely silent. The cloud does not break apart suddenly. It tightens little by little, allowing new stars to take shape with patience rather than force. This gradual trigger shows that beginnings can come from events that have already ended. The universe recycles energy softly, turning the fading light of old stars into the quiet birth of new ones without rushing any part of the cycle. Light from distant stars can bend gently when it passes near massive objects like galaxies or clusters. This effect is called gravitational lensing, predicted by general relativity. The bending does not harm the light or change its nature. It simply alters its path, creating magnified or repeated images that allow scientists to see objects too faint or far away to view directly. The process is peaceful and requires no interaction beyond gravity itself. Gravitational lensing shows that the universe can reveal hidden places not through force, but through simple curvature in space. It is a quiet reminder that even the smallest change in direction can open new ways of seeing without disturbing the light that continues on its journey. Inside the cores of stars with enough pressure, hydrogen exists in a strange form known as metallic hydrogen. In this state, electrons move freely, allowing heat and energy to pass through with ease. The transformation does not happen suddenly. It requires slow compression over millions of years as the star adjusts its internal balance. Metallic hydrogen cannot be observed directly inside a star, yet its presence explains why energy flows gently from the core toward the surface. The process shows that unseen structures can support calm stability. Even in intense environments, the universe creates order rather than chaos. Metallic hydrogen reminds us that strength can stay hidden, working quietly to maintain balance without revealing itself outwardly. Across the universe, countless stars contribute to a faint background glow known as the cosmic optical and infrared background. This soft light is not bright enough to see with the naked eye, but it surrounds us from every direction. It comes from ancient stars that lived and faded long before galaxies took their current shapes. The glow is gentle and steady, like a memory that never disappears completely. Scientists study this background to understand how early stars formed and how the universe changed over time. Even though individual stars are gone, their light continues drifting quietly through space. The background shows that nothing luminous truly vanishes. It simply becomes part of a softer and more distant radiance. Around many stars exists a region where temperatures may allow liquid water to exist on planets. This area is called the habitable zone, sometimes referred to as the Goldilocks zone, where conditions are neither too hot nor too cold. The size and location of this zone depend on the star's brightness and temperature. For small red dwarfs, it lies close to the star, while for large bright stars, it stretches farther away. The concept is calm and simple. Distance shapes possibility. Not every planet in this region will support life, but the idea offers a gentle sense of hope. Stars provide quiet environments where worlds can exist in balance, reminding us that potential often grows in peaceful spaces. Planets that orbit very close to their stars can become tidally locked, meaning one side always faces the star while the other remains in darkness. The process happens slowly as gravitational forces reshape the planet's rotation until it settles into a stable rhythm. Despite the extreme contrast between light and shadow, the system remains calm and predictable. Winds and heat may circulate gently, redistributing energy over long periods of time. Tidal locking shows that balance can exist in surprising ways. Even when two halves experience different conditions, the world continues without disruption. The universe supports quiet stability by letting motion adjust naturally rather than forcing sudden change. Near the end of a star's life, when the core can no longer support its increasing weight, a sudden but internal adjustment called the helium flash occurs in stars like the Sun. Although the name suggests something explosive, the event is not visible from the outside and produces no outward disturbance. It happens deep within the core, allowing the star to continue shining steadily for millions of years afterward. The helium flash demonstrates that major changes can take place quietly, without drawing attention. The star transitions into a new phase with grace, showing that progress does not always require outward signs. Sometimes the most important transformations happen unseen, while the surface remains calm and familiar. Many stars and spiral galaxies form along the bright arms that curve outward from the center. These arms are not solid structures, but regions where gas and dust move more slowly, causing material to gather and compress. The stars within them do not travel along the arms like cars on a road. Instead, they drift in and out as the galaxy rotates. The arms remain visible because new stars continue forming there over long stretches of time. Spiral arms show that patterns can remain stable even when individual parts are constantly changing. The galaxy maintains its graceful shape without needing stillness, offering a calm example of motion and structure working together. Interstellar dust can gently dim the light from stars, causing them to appear fainter and redder than they truly are. This effect is called interstellar extinction, and it happens because tiny particles scatter blue light more than red. The process is soft and gradual, with no impact on the stars themselves. It simply changes how we see them from far away. By studying this dimming, astronomers learn about the dust between stars and map the structure of the galaxy. Interstellar extinction shows that appearances can be altered by the space between us and what we observe. The stars remain unchanged, reminding us that clarity sometimes depends on perspective rather than brightness. Modern star catalogs contain precise information about millions of stars, including their positions, brightness, and motion across the sky. Space missions like Gaia measure these details with remarkable accuracy, creating a calm and detailed map of the Milky Way. The data does not change the stars themselves. It simply allows us to understand their journeys more clearly. Over time, these measurements reveal slow patterns that would otherwise go unnoticed, such as the gentle drift of stars across space. Cataloging is a quiet act of observation, built on patience rather than urgency. It shows that knowledge grows through steady attention, allowing the universe to reveal itself in small and peaceful increments. Some stars drift through the galaxy without belonging to any system or cluster. These are called field stars, moving independently through space at their own gentle pace. They were not always alone. Many formed in groups, but slowly separated over billions of years as gravity guided them along different paths. Field stars remind us that solitude in the universe is quiet rather than empty. They continue shining without needing companions, maintaining their rhythm while the galaxy turns around them. Their steady presence shows that independence does not mean isolation. A star can travel peacefully through space without losing its purpose, carrying its light across vast distances while leaving room for others to follow their own paths. In very dense star clusters, close encounters between stars can change their motions without collision. Gravity gently redirects their paths like slow and silent choreography. These interactions happen over long periods of time, shifting orbits and gradually spreading stars apart. Nothing is rushed or violent. The cluster remains stable even as its members slowly drift outward. This process shows that influence does not require force. A simple gravitational presence can shape motion softly, allowing stars to adjust without disturbance. Over billions of years, the cluster thins and eventually dissolves into the galaxy, leaving no abrupt ending. The transformation is natural and calm, reminding us that change can be smooth when time is allowed to work gently. Stars breathe in their own way by balancing pressure and gravity. As fusion in the core produces energy, the outward pressure supports the star against collapse. When the fuel supply slowly decreases, the balance shifts, and the star gently expands or contracts to restore stability. This delicate adjustment happens gradually, without sound or sudden motion. The star simply settles into a new state, continuing its life at a different temperature or brightness. The process shows that balance is not fixed. It responds to circumstances with small and thoughtful changes. Stars remain steady because they adjust instead of resisting. Their calm behavior reflects the quiet strength that comes from flexibility rather than force. Some stars contain strong internal layers that trap sound waves, allowing vibrations to travel through them like gentle echoes. These oscillations cannot be heard because sound cannot pass through space, but instruments can detect the subtle changes in brightness they create. By studying these vibrations, a field called asteroseismology reveals information about a star's internal structure. The process is peaceful and relies only on patient observation. Stars share their secrets, not through noise but through soft patterns that repeat over time. These hidden vibrations show that activity does not have to be visible to be meaningful. Even deep within a star, motion exists quietly, supporting stability while remaining unnoticed from the outside. In some regions of the sky, stars appear grouped together, not because they are physically close, but because we see them along the same line of sight. These are called asterisms, familiar patterns that help people recognize the night sky. The Big Dipper is one of the best-known examples, forming a comforting shape that has guided travelers for centuries. Even though the stars lie at different distances, the pattern remains steady from Earth. Asterisms remind us that perspective shapes what we notice. Meaning can arise from simple arrangements without needing physical connection. They turn the sky into something familiar, offering gentle orientation in a space that might otherwise feel overwhelming. Some stars shine with unusual chemical compositions that reveal unique histories. These chemically peculiar stars contain elements on their surfaces that are either enhanced or depleted compared to typical stars. The differences develop slowly as magnetic fields and rotation move material within the star. Although the process is complex, the result is calm and steady. The star continues shining while carrying a quiet record of its internal changes. Studying chemically peculiar stars shows that individuality exists even among objects that appear similar. The universe allows variation without disruption, creating diversity through subtle adjustments rather than dramatic events. These stars remind us that uniqueness can be gentle and still remain part of a larger harmony. Binary stars can exchange mass when one expands during its late stages and gently transfers material to its companion. The process may continue for thousands of years, creating a smooth and stable flow rather than a sudden release. The receiving star grows brighter, while the donor becomes lighter, yet both remain in balance. This exchange shows that giving and receiving can happen gradually, without loss of structure or harmony. The system continues moving in its shared orbit, unchanged in motion, even as both stars evolve. Mass transfer demonstrates that interaction does not need conflict. The universe supports cooperation in quiet ways, allowing two stars to share resources and remain stable across great stretches of time. When dust and gas reflect the light of nearby stars, they create soft regions called reflection nebulae. These clouds do not shine on their own. Instead, they scatter starlight into gentle blue hues that appear smooth and calming. The light is not intense, and the glow can last for millions of years, as long as the illuminating star remains nearby. Reflection. Nebulae show that beauty can come from borrowed light. They exist quietly, without heat or dramatic change, transforming simple surroundings into something peaceful and luminous. Their presence reminds us that brightness does not always originate from within. Sometimes it comes from being close to something steady and allowing that light to spread softly across space. Stars that rotate slowly tend to have calmer surfaces with fewer magnetic disturbances. Their gentle rotation allows heat and energy to rise smoothly from the core to the surface, creating a stable and balanced environment. Slow rotators often remain steady for billions of years, changing only at a pace too gradual to notice. This quiet stability supports long-lasting planetary systems, giving worlds time to form and maintain orbits without disruption. The behavior shows that speed is not always beneficial. Moving slowly can create peace and reliability. Stars remind us that stillness can exist even while rotation continues, proving that motion does not need to be fast to be meaningful or effective. Over long periods of time, star maps shift as stars slowly change their positions in the sky due to proper motion. The movement is incredibly small from year to year, yet over thousands of years, constellations gradually alter their shapes. Ancient patterns remain recognizable, but are not permanent. The change happens so gently that no one notices it within a single lifetime. This gradual drift shows that nothing in the universe is completely fixed. Stability exists, but only within certain spans of time. The sky teaches that change can be natural, slow, and without disruption. Even the stars adjust their places calmly, reminding us that everything evolves in quiet ways we may never see directly. Young stars called T Tauri stars represent one of the earliest stages of stellar life, forming just after a protostar begins to shine. They are still gathering material from the cloud that created them, surrounded by gentle disks of dust that may one day become planets. Their light can flicker softly as surface activity settles into balance, but the changes are not harmful or abrupt. Everything unfolds slowly, while the star learns to stabilize its temperature and rotation. T Tauri stars remind us that growth can look unsteady without being rushed. They are simply adjusting to the start of a long journey, glowing with a quiet promise that time and patience will guide them into the steady brightness of adulthood. Red supergiants are among the largest stars in the universe, expanding to sizes that would reach far beyond Earth's orbit if placed in our solar system. Despite their immense scale, they shine with a soft and cool light compared to hotter stars. Their outer layers drift outward gently as the core changes slowly over time. Well-known examples like Betelgeuse appear calm from across space, even though they are approaching the final stages of their lives. The transformation is gradual and measured, taking millions of years to complete. Red supergiants show that endings can be grand and peaceful at the same time, allowing a star to fade with dignity rather than sudden collapse or noise. Some systems contain 3 stars bound together in a quiet and stable arrangement. These triple star systems can form when 2 stars orbit closely, while a third moves around them at a much greater distance. The motion appears complex, yet the gravitational balance keeps everything steady for long periods. From Earth, they may look like a single point of light, hiding the gentle harmony within. Over time, their orbits shift in small ways, but rarely break apart. Triple systems show that relationships can take more than one form and still remain peaceful. The universe supports many kinds of companionship, allowing different paths to stay connected without conflict or disruption as they continue their shared journey through space. Some stars reveal their presence not through visible changes in light, but through a soft and gradual wobble in their position. These are called astrometric binaries, where one star is hidden from view, but gently pulls on the other as they orbit together. The motion is too small for the eye to notice, yet precise instruments can detect it over many years. This silent interaction allows astronomers to learn about stars that cannot be seen directly. The system remains stable and calm, showing that influence does not require brightness or sound. Astrometric binaries remind us that subtle movements can tell meaningful stories, and that quiet partnerships can shape the universe without calling attention to themselves. Around most galaxies lies a faint and extended halo filled with old stars drifting slowly through vast space. These stars do not form in dense clusters or bright regions. Instead, they exist at great distances from the center, moving in long and gentle orbits that take billions of years to complete. The halo is nearly invisible to the eye, yet it holds clues about the earliest stages of galactic history. Its stars are ancient and quiet, shining softly without interruption. The halo shows that not everything important lies at the center. Sometimes the outermost spaces carry the deepest memories, waiting patiently to be understood. The universe keeps these distant lights as reminders of how calmly time can preserve its oldest stories. Astronomers can estimate the age of certain stars by studying how quickly they rotate, a method known as gyrochronology. Young stars spin rapidly, while older stars slow down over long stretches of time, as magnetic activity gently reduces their speed. The process is gradual and cannot be noticed within a single lifetime. By measuring rotation, scientists gain quiet insight into a star's past without disturbing it. The method reflects a peaceful truth. Even something that seems unchanged carries hidden signs of experience. Gyrochronology shows that aging in the universe is not marked by sudden shifts, but by slow adjustments that unfold with patience and consistency, allowing stars to continue shining while time moves softly around them. Earth's axis slowly changes direction over thousands of years in a motion called precession, causing the identity of the pole star to shift over time. Today, Polaris appears almost fixed in the northern sky, offering steady guidance to travelers and observers. Long ago, a different star held this position, and in the distant future, another will take its place. The change is so gradual that no one notices it from one generation to the next. The sky appears constant even as it evolves with gentle precision. Precession shows that stability does not require permanence. The universe allows slow transitions that never disturb the calm experience of watching the night sky, reminding us that change can happen without altering peace. When light from a bright event such as a supernova reflects off nearby dust, it creates a soft phenomenon called a light echo. The original burst may have faded long ago, yet its reflection travels outward slowly, appearing years or even centuries later. The echo does not repeat the explosion's power. It arrives quieter and gentler, like a memory returning in a softer form. Observing light echoes helps astronomers understand past events that can no longer be seen directly. They show that moments do not always vanish when they end. Sometimes they return with calm clarity, offering a second glimpse without noise or urgency. The universe keeps reminders in delicate ways, allowing light to linger long after its source has faded. RR Lyrae stars are gentle, variable stars found mostly in old clusters and galactic halos. Their brightness rises and falls in steady, repeating cycles that last only a few hours, yet the pattern remains reliable over long periods of time. Astronomers use these stars as natural distance markers because their behavior is consistent and predictable. RR Lyrae stars do not change dramatically as they age. They continue their quiet rhythm while holding some of the oldest histories in the universe. Their soft pulsations show that repetition can be peaceful rather than restless. The universe uses these subtle signals to measure space with calm precision, proving that even the smallest variations can guide understanding across immense distances. Dwarf galaxies contain far fewer stars than large galaxies, yet they continue forming new ones in slow and gentle bursts. These small systems drift around larger galaxies like quiet companions, influenced by gravity but maintaining their own identity. Star formation in dwarf galaxies happens gradually, without the bright and crowded regions seen elsewhere. The process can pause for long periods before starting again, reflecting a natural rhythm that never seems rushed. Although faint and easily overlooked, dwarf galaxies play an important role in the universe by preserving early conditions and contributing stars over time. They remind us that significance does not depend on size or brightness. Even the smallest collections of starlight can add to the calm structure of the cosmos. Some stars spend their entire lives in quiet isolation on the outer edges of dwarf galaxies, far from crowded regions where new stars are born. These remote stars drift through space with almost no outside disturbance, completing long and gentle orbits that take billions of years. They shine softly, unaffected by interactions that reshape stars in busier environments. Their calm existence helps astronomers understand how galaxies formed and changed over time, because these stars preserve early conditions that remain mostly untouched. Even though they are faint and distant, they hold valuable clues about the universe's past. Their steady presence shows that peace can last across unimaginable time, and that stillness has a place even in a universe filled with motion. Some stars cool enough to form molecules in their outer layers, creating subtle patterns in their light. These molecules do not change the star's behavior. They simply absorb and reflect certain colors, producing gentle variations that help scientists identify temperature and composition. The process happens slowly as the star evolves, allowing the atmosphere to shift without sudden transformation. Molecular features act like quiet markers that reveal what is happening on the surface without disturbing the star's natural rhythm. Studying them shows that detailed information can come from soft and delicate signals. The universe shares knowledge in calm ways, offering insights through tiny changes that would go unnoticed without patience and careful observation. Hypervelocity stars travel through the galaxy at extraordinary speeds, sometimes fast enough to escape it completely. These stars are rare and usually gain their momentum after passing near a supermassive black hole, which redirects them without contact. Despite their high speed, they move silently through space, far from causing disruption. Over millions of years, they drift into the darkness between galaxies, continuing their journey alone. Hypervelocity stars show that even dramatic motion can unfold quietly, without visible disturbance. Their paths are smooth and steady, guided only by gravity. They remind us that change can happen in a single moment, yet still lead to a long and peaceful future, shaped by patience rather than chaos. Some stars experience gentle cycles of surface activity that create long-term changes in brightness. These stellar cycles are similar to the Sun's 11-year pattern, but can last decades or even centuries. The changes happen slowly and do not harm the star or surrounding space. Instead, they reveal the natural rhythm of magnetic fields as they strengthen and weaken over time. Observing these cycles helps scientists understand how stars maintain balance across long stretches of their lives. The process shows that variation is a normal part of stability, not a sign of disorder. Stars teach that calm systems can include soft rises and falls, and that consistency does not require complete sameness from one moment to the next. Stars in the thick disk of the Milky Way move differently from those in the thin disk where the Sun is located. They follow higher and more tilted orbits, passing gently above and below the galactic plane over long periods. These stars tend to be older and contain fewer heavy elements, reflecting an earlier stage of the galaxy's history. Their motion is steady and predictable, creating a quiet bridge between the halo and the busy central regions. The thick disk shows that the galaxy is layered in calm and gradual ways, shaped by time rather than sudden events. It reminds us that structure can develop slowly, with each part contributing to a larger harmony that continues without interruption. Some stars form in pairs that are so close together, they eventually merge into a single, larger star. The process is not sudden. Over millions of years, their orbits shrink as they exchange small amounts of energy. When they finally combine, the result is often a stable star that continues its life quietly, shining with renewed brightness. From far away, nothing appears dramatic. The transition happens inside the star's own boundaries, leaving no lasting disturbance in surrounding space. Stellar mergers show that transformation can bring unity rather than destruction. The universe allows change to unfold softly, turning two separate paths into one calm and steady future that continues without breaking the natural flow of time. Some stars emit gentle streams of particles that interact with surrounding gas, creating faint bubbles or shells known as stellar bubbles. These structures expand slowly, shaped by the steady pressure of the star's wind rather than sudden force. The bubble remains visible only while the wind continues, fading gradually as energy disperses. Stellar bubbles reveal how stars influence their environment without noise or violence. They reshape space through persistence rather than intensity, proving that long-term effects do not always come from dramatic moments. The universe works through processes that unfold patiently, allowing small, continuous actions to create quiet beauty across large distances without disturbing the balance around them. In very young star clusters, the brightest stars reach maturity quickly, while smaller ones take much longer to settle into stable stages. This difference creates a gentle mix of ages within the same region, even though all stars formed at nearly the same time. The cluster remains calm as each star progresses at its own pace. Some will begin shining steadily, while others are still adjusting. The scene shows that development does not follow a single schedule. The universe allows every star the time it needs, without rushing or delaying the rest. Young clusters offer a peaceful example of patience, where shared beginnings lead to different rhythms that coexist without conflict or pressure. Some stars become so cool in their later stages that their light shifts toward deep infrared wavelengths, making them invisible to the human eye. These stars continue shining softly, even though their glow can only be detected with special instruments. They have not faded entirely. They have simply moved into a quieter form of existence. Observing them helps astronomers understand how stars finish their lives without sudden endings. These infrared stars show that brightness is not the only measure of presence. Even when light becomes faint, it still carries warmth and memory across space. The universe allows gentle fading rather than disappearance, letting stars complete their journey with calm and silent dignity. In galaxies undergoing slow and steady star formation, new stars appear at a relaxed pace rather than in bursts. Gas clouds collapse only when conditions are right, leading to generations of stars that form over billions of years. These galaxies remain stable and balanced, producing starlight without dramatic peaks or declines. The process reflects a natural rhythm where creation unfolds gradually. Observing these galaxies shows that progress does not require intensity. It can come from consistency and patience. The universe builds many of its structures quietly, allowing time to shape every step. Slow-forming galaxies remind us that lasting change often comes from gentle beginnings that continue without force, guided by steady and peaceful evolution. As the night grows quieter, let the stars above fade softly into the background. You don't need to remember every fact or every moment. Just rest in the thought that the universe moves at a slow and steady rhythm, and you are part of that same quiet flow. The sky will still be here tomorrow, carrying the same patient light and the same familiar calm. If your eyes are getting heavy, allow them to close and drift with the silence. Let your breath settle, slow and comfortable, like starlight taking its time to reach across space. You are safe, you are still, and the world can wait. Sleep well, and when you wake, the stars will be waiting for you. Good night and sweet dream.